And we are live. Hello, everyone. Welcome to the Somnia Codelabs. My name is Emmanuel, and I am with the developer relations team here at Somnia. As always, it is my delight to anchor these sessions. And of course, in this edition, we'll be having a session on Protofire price feeds on Somnia. And it's my pleasure today to be featuring a very special guest from the Protofire team. Hello, Rodrigo.
Hello, Emmanuel. How are you?
Very well. Same here.
Nice to be
It's a
here.
pleasure and a delight. And thank you for making yourself available and doing this. Just before we dive into the core session, I just want you to kindly briefly share a brief introduction about yourself and what it is that you do at Protofire.
Okay. Um, okay, just focusing on me, not on Protofire. I mean, you already had a Codelab session with some colleague from Protofire. I'm working in Protofire since 5 years ago. My role is basically smart contract or Web3 architect, mostly focused on the smart contracts. I joined it here as a Solidity developer. Moving forward, I worked in really several projects since the last 5 years, mostly of them related with DeFi. That means creating protocols from scratch. Another thing worth to mention, my expertise is completely focused on EVM. So all my work and everything what I know is directly focused on EVM chains. So just to mention the kind of work that I have been doing these years here is, as I mentioned, designing, implementing, auditing, testing smart contracts and protocols from scratch, forking, extending existing protocols. Um, I don't know. I suppose if you go to profiles, you're going to see like we already work with a lot of major names on Web3 ecosystem. And basically, that's what I'm doing here. Another thing, I moved into a more architectural role the last years because I'm basically leading some um, teams of developers, still writing some code, but the majority of my work is on designing protocols, designing software, and deciding how the things are going to be built, basically. So that's pretty much all.
Thank you very much for that brief introduction, Rodrigo. And then, just before we get into the full code lab session, a few ground rules, everyone. It's a delight again to have you joining in. And I know that you'd have a lot of questions for Rodrigo for this session. And please note that you can send in your questions via X or on YouTube, depending on where you are watching the session on. So just leave the questions in the thread in the comments if you're on X, and also leave it in the comment section if you're also on YouTube. And we would answer them at the end of the session. Please just be reminded that we need to be civil and keep the questions to the topic being discussed. And then to every any other technical questions that you may have about Somnia and of course about Protofire, not just the tooling that's going to be discussed today, but if you are conversant with the Somnia docs and you want to leverage this opportunity to ask other questions about the Protofire dev tooling services, of course, this is an opportunity for you to get answers to your questions in real time. And of course, this session will always be available to you on YouTube, where you can go rewatch the session. Thank you very much, and handing over to Rodrigo right now to lead the rest of the session.
Thank you, Emmanuel. Okay, basically, what I will be doing is talking a little bit about Oracle price feeds. Price feeds in general, like which are digging into the what is the concept behind these, what are the challenges, which are the recommended way to actually use it. Then we're gonna see some examples of price feeds in Somnia. And we are gonna have a demo. It's a really simple thing with a public repository you're gonna be able to check out. So let's start. Let me see. Okay, the agenda is this is basically what we have. What are price feeds? Why they matter? The Oracle problem, Chainlink's solution to that, common attack vectors, trusted price feeds on Somnia, how to use the price feeds, as I already mentioned, best practices, custom price feeds, and then you're gonna go just directly to the code. Okay, I already presented myself. The topic I'm gonna be talking here. Just something to mention here. I am assuming the audience is not an expert on the field, so it's really a simple thing. I mean, the concept that we're going to cover are pretty much simple if you're a smart contract dev. Um, but if you're not, or you're more, or I don't know, maybe a web developer or something like that, maybe you're gonna find this useful to get introduced into what we are doing with price fees and how you can use them and so on. Okay, first, what are price feeds? Basically, the definition is as simple as this: it's off-chain data that goes on-chain via oracles, and in particular, when we say oracles are the way in which we can pull data from the real world, from the off chain, let's say, into smart contracts. And price feeds are a specific type of oracles that we use in order when we need to fetch prices of assets that are processed off chain typically. But we're going to see some examples. Maybe basically I'm going to mention and explain a little bit some types of other price feeds we can use. And we have been using those on many projects already, and which is basically not depending just on oracles. I mean, not just pulling data from off chain, but actually calculating price and asset prices on chain. Okay, let's go on. Why they matter? It's kind of obvious thing, but worth to mention. This is completely a key thing into almost every DeFi protocol. I mean, it's kind of difficult to think about some protocol I have been building things on and I didn't use price feeds somehow. I mean, they're involved everywhere and they're absolutely critical aspects of security in the smart contracts logic. So they power DeFi and gamify use cases, at least that, but probably more than just that. The challenges are basically, can you trust in the data that you're consuming? I'm saying this because something that needs to be understood is when we are working on, I mean, again, assuming I'm not talking just to Web3 developers, this is for generalist kind of dev or tech guys. Things on smart contracts are absolutely critical in terms that you normally can, when you break something, maybe you can absolutely lose a lot of money, and maybe you can even not recover from that. So that's why I'm saying trust, data integrity, timeliness, and network reach are so absolutely critical things, and are actually big challenges. That's why solutions like Chainlink already exist. Um, Another thing, I mean, no, it's not another thing, it's related about the thing, why they matter, why they specifically matter, why we're doing probably a separate, we're having a separate conversation just about this. Maybe you're going to have the interpretation at the end that this is a small thing that is too specific because it's one particular thing, one particular way to uh, get data into your smart contract. But the thing is that you're trusting normally in some kind of single source of truth, and that's something that it's key and critical into any smart contracts architecture. I'm gonna tell some recommendations about how to treat them. And what is obvious is basically that without them, the contracts are blind to market data. Okay, the Oracle problem. Contracts trust Oracle data implicitly. That's true. That's what I'm saying. The risks are related with manipulation, stale prices, and single point of failure as you're putting this central failure point into your architecture. Let's see how we can um, um, uh, solve those challenges. Okay, Chainlink's solution, I'm mentioning Chainlink because it's the biggest and the most widely adopted. It's a really huge player, has been years working in this ecosystem. So um, basically, it's a decentralized networks of nodes. It aggregates multiple sources of data. It pushes on-chain aggregator contracts, which are the particular contracts that we are going to use in order to consume data from the that is off-chain. It has already its internal incentive design of the protocol itself, of Chainlink, that basically incentivize honest reporting, and as I already mentioned, like absolutely proven reliability across several networks. Um, is definitely a battle tested protocol and solution. Just to be clear, I mean, because I mean, again, I'm used to just already talk with people that already has a lot of context about this. But when we say decentralized network of nodes, it is basically an independent node network from, for example, Somnia in this case, or Ethereum, or any other EVM. They have their own stack, their own infrastructure, and their own incentive mechanism. That means that when you're building smart contracts and you want to consume data from Chainlink oracles, so in particular from price feeds, you don't need to pay the Chainlink for consuming that data. They just pushing, they're constantly securing the network to have this well incentivized actors pushing data into these oracles. So they're just available in the on any chain that they're supporting. So you can just go and use their aggregators and read the data. We're going to see how they do that in particular. Okay, so common attack vectors. Okay, flash loans, price move. I will explain a little bit what I'm saying in each case. Flash loan price manipulations. This is normally, I think, I mean, it is something that happens on chain. Is not particularly something that affects price feeds that are consuming data from Chainlink. It mostly affects another type of price feed that worth to mention right now, which is TWAP, which is means, I mean, TWAP are the letters, the TWAP, which is time weighted average price. I think the translation of that is basically something that surged from decentralized exchanges. I think Uniswap is probably the first that introduced this. Maybe I'm wrong about that, but I'm not making. I mean, I'm not talking about history. It's just what I used to use. The concept around this is that when decentralized exchanges implement pools that basically provides they concentrate liquidity and rebalance have a mechanism of constant rebalancing between two tokens, two at least, but let's say two for now for simplicity. um, you can actually query on chain directly to those, um, I mean, to how the price is moving into the pool itself. For example, let's say, I don't know, Ether and USDC. Okay, so you want to know the price of Ether denominated in USDC, so you can query on two apps price feeds. The thing, I mean, you can use those as oracles. The thing is that why TWAP exists, what I mentioned, this particular time weighted average price mechanism, is because you cannot just query one particular um, one particular price at one particular moment and just trust in that, because you need something that gets weighted into some range, into some time range, and basically that needs to be. I mean, we do that because if we don't, it will be just too easy to attack the price reporting. I mean, any bad actor can assume the cost of moving the market with some kind of big trade. That's why I'm mentioning flash loans. Flash loans means that you're in the same transaction, you're getting a loan, you're doing something with that, and then coming back and paying back the loan in the same transaction. So that means that you can manipulate what the I mean, you can manipulate the price of the pool, but normally for a short period of time. How short depends on how much you're willing to pay. So the thing is, by using TWAPs, we discourage this type of attack. Okay, let's move forward because I just dedicated too much time to that. Sell price exploitation, basically, uh, wrong. I mean, when you're trusting in price reporting and you're not like checking or controlling when was the last time that price has been updated, you can be attacked by that. It's just as simple as that. Another thing is centralized Oracle compromise. This is something that could happen, for example, if you're implementing your custom price reporting mechanism and you're just pushing your data on chain without any kind of decentralized network like Chainlink or something like that. If your infrastructure gets compromised, or your I don't know, if the let's say that you have a permissioned account that has permissions to basically run a transaction and update some price reporting in some contract. Okay, basically, if you're doing that and trusting that just in your infrastructure, you can be attacked. Uh, and the mitigation are basically decentralization, validation, correct unit handling. In particular, correct unit handling is something I will talk about later. It's basically when you're using different price fits, and if your architecture like mixes several different denominations, which is pretty common in some cases, you need to be aware about decimals. This is some kind of obvious thing, but decimals are, uh, I mean, I'm saying this from my experience. I have seen devs, and maybe even myself at some point, dedicating pretty much time to fix issues about decimal calculations and rounding and those kind of things. It depends on how critical your functionality is. It depends on what you're doing, why you're what you're doing with the price that you're acquiring and consuming. But it could be real critical to just